Example 3, we're going to find the reciprocal of the complex number 2 minus 3i. And reciprocal just means 1 over u. So we're going to be computing what's called the inverse of the complex number 2 minus 3i. That's also known as the reciprocal. So that means what we need to do is we need to compute 1 over 2 minus 3i. This here represents the reciprocal. Now, from the previous example, we know that whenever we're dividing complex numbers, which is what we're doing here, 1 is a complex number. It's like the complex number 1 plus 0i. And 2 minus 3i is certainly a complex number. We multiply by a careful choice of 1. And this is our careful choice of 1. 2, and then we change the sign of the imaginary term. So 2 plus 3i over 2 plus 3i. All right. So let's carry out the complex arithmetic. So 1 times 2 plus 3i is 2 plus 3i. And then in the last video, we saw whenever you multiply a complex number by its conjugate, you square the real part, and you add that to the square of the imaginary part. And it doesn't matter if I put negative 3 in parentheses squared, like this, or positive 3 squared. The squaring function doesn't understand negative signs, so you get the same answer. All right, 2 squared is 4. 3 squared is 9, so we're doing 4 plus 9, that's 13. And then we divide each piece. And we're done now because we have computed an expression that looks like a real number plus a real number times I. We're going to do an additional step here, actually, though. This guy here is supposed to represent the number 1 over z. Or we may also even write this as z inverse. So z to the negative 1 means the same thing. Now what's special about this is when we take z and we multiply it with z inverse, if there's justice in the world, this should be a 1. So let's check. So that's z. And here's our z inverse. And we agreed that, let me scroll down here for a second. We agreed that whenever you're multiplying complex numbers, you just FOIL and remember that I squared is negative 1. So we're going to get 2 times 2/13. Again, being somewhat careful with my parentheses here. 2 times 3/13 I plus negative 3i times 2/13. And then plus negative 3i times 3/13 I. So we're going to get 4/13 plus 6/13 I minus 6/13 I minus 9/13 I squared, if I did that right. The middle terms here cancel. They're equal and opposite in sign. And that I squared we can rewrite as a negative 1. So negative 1 times a negative is a positive, so that's really a plus 9/13. 4/13 plus 9/13 is, of course, 13/13, which is 1, and we've done it. Similarly, if we multiply on the left by z inverse, we also get 1. And so this also satisfies what we should think about as this complex number 2/13 plus 3/13 I satisfies what we should think about as the inverse of our complex number. And let me just note here, with complex numbers, computing the inverse is more complicated. We weren't done by just putting the complex number in the denominator. We actually had to carry out to make it look like this is called rationalizing. We had to rationalize so that we got what looks like a complex number. So there's a little bit more work here in computing inverses.